Hello, this is Jack Jackson. We're going to start a little section here now on inferences about proportions. Proportions are really second only to inferences about means, and inferences about proportions are talking about proportion of successes in a population. They're very important. This larger section here deals with the confidence intervals and hypothesis test about proportions. As we studied in Unit 2B, probabilities concerning distributions of proportions properly use either a binomial or hypergeometric distribution. Recall that when we were making inferences about means using a z-test or t-test interval, we were making inferences about numerical data for which means make sense. Often we are interested instead in making inferences about proportion successes in discrete data. Examples would be proportion of voters supporting a particular candidate, proportion of patients responding to a certain treatment, proportion of students passing a class, proportion of defective parts manufactured, and many, many more. Here's the breakdown of the basic sections within this larger section about proportions. This video will just have this short introduction, and then there'll be a video on review of distributions of proportions, reviewing some things about the binomial and hypergeometric distributions. Section 4.7.2 will be test of proportions using a hypergeometric distribution. Then we'll go to test of proportions using a binomial distribution. Then we'll talk about approximating hypergeometric and binomial distributions with a normal distribution. We'll do a one proportion z-test and one proportion z interval using the calculator shortcuts. And then I'm going to introduce a TI-84 program for hypothesis test of proportions, which actually takes care of the hypergeometric, binomial, and the normal approximations all. And we will do then two large sample inferences proportions where a normal distribution approximation makes sense using a two proportion z-test and interval using the shortcuts on the calculator.